All right, so this should be the video for 11.3, which is going to be on the derivatives of products and quotients. And so we're going to be talking about both the product rule and the quotient rule. This is applying derivatives to multiple functions which are multiplied together. Could also be just like constant times the function as well, and then you apply it, and you'll come up with some simplifications in those cases. But this is a general rule that works for two functions being multiplied together, and we'll see how this works here in a second. But for the first one, we have theorem 1 for this being the product rule. And so if we have y equals f of x equals g of x times h of x, which g of x and h of x are two functions, then we would have f prime of x equaling g of x times h prime of x plus h of x times g prime of x. So what we've done here is we've basically taken the derivative of one of these two functions and then multiplied it by the other function, which was not differentiated first off. And then we differentiate the other function and multiply it by the first function. And we add those two terms that we just got together to get the full derivative for this function. And there are a couple of case examples that you can do. Like if you're testing out this product rule here, you can do it with x squared and just say that g of x is equal to x and h of x is equal to x, and then test out what happens with the product rule. And that's a good little example to kind of go through. You can also do it with a constant times some function and then see what happens. Those are both good cases to just sort of see as an example and understand how the functions can relate back to these base cases that you can build off of. Other notations that are useful for this particular product rule are looking at y prime equal to g times h prime plus h times g prime. This is the same statement as what we had right here, but it's just rephrasing it in more of a simplified notation, which makes things a little bit more compact and digestible. There's also the notation which is predominantly used in differential equations and such, which is this differential notation. And this is dy over dx equals g function times dh over dx plus h function times dg over dx. And this notation is something that I do think would be good for you to know if you were going into differential equations, because it gets used a lot to be able to relate between different functions that are being differentiated between each other. And so knowing this and seeing this product rule is very useful for that particular class if you're going into it. It's just good to kind of see this in general. Let's go ahead and take a look at the quotient rule now. So for the quotient rule, which is theorem 2 in this section, if y equals f of x equals t of x over b of x, then f prime of x equals b of x t prime of x minus t of x b prime of x, all over b of x quantity squared. And so this derivative here is very cumbersome in terms of calculations and in terms of notation. So be very careful whenever you're doing the quotient rule. This can be somewhat tricky to remember the order, because potentially if you do what you're thinking of with the product rule and you end up with switching just where the top and the bottoms have their derivatives in this top part here, you can end up with the negative of the result that you actually want. And so remember to be very careful and very meticulous about how you apply the quotient rule, because it's not commutative like you would have with the product rule, where you could potentially commute the g of x function and the h prime function, as well as the terms themselves of this g of x, h prime of x, and the h of x, g prime of x, since it's additive or addition is commutative. So be careful here that since subtraction is not commutative, that you don't switch where these are. That's just a side note with this that you have to be careful of. The quotient rule is very specific in how it's written and very specific in its notation on where the derivatives are. And so just remember all of that and be very careful about applying it. As far as the quotient rule goes, it's useful for finding the derivative of rational functions. There is the potential that b prime of x and t prime of x might have regions where they're not explicitly defined just by the virtue of what their functions are. So in those cases, the f prime of x would not be defined in those regions, but otherwise it's fine. Rational functions, they're defined on all rational functions because of at least ones that have polynomials, because polynomials are differentiable everywhere. And so these t of x and b of x, if they were polynomials, this would be fine for everything. It might have a couple of undefined areas because of the polynomial in the denominator, but that's a problem for a later date. So think about the quotient rule as a very strict guideline for how to do the derivative of something that's a fraction or has functions which are divided by other fractions. And so, or other function. And so be careful about how you're applying this. And it's a very tricky rule. And I've seen a lot of people kind of get tripped up on it. So it's very good to be very careful with applying this to your problems, especially if you get asked about it. Okay, so that should be the end of the product rule and quotient rule section. So I'll go ahead and get the next section ready for you guys. So talk to you soon.